Hello, physics people again. I'm going to do a little bit about forces on things that are stacked up, because a lot of times they will give you a stack of something or even a bunch of things that are moving along together like this, and they will want you to draw what forces are on these things. And remember, the forces are found by isolating what they want you to find the forces on. So you wouldn't include A in looking. So if they said find all the forces acting on B, you would circle. Then you would put a dot where it's touching something else. So we can see so far B, you can always put the remote force first. So if this is B, then you have mg, okay? Always. That's your remote force. Anything that's sitting on this earth is going to have mg affecting it. Then here, the table is acting on that, because don't forget, Newton's third law says that everything has an equal and opposite force. Equal and opposite. Remember we used to talk about the bug and the truck? The force is equal, it's just the acceleration is so much more for the bug. That's why it ends up splatted. So if you look at this, the normal force of the table is acting upward, but there's also another force acting on this. The force, we can call it the force of A on B, is acting on it. So the force of A on B is also a downward force. Okay? Force of A on B, mg. So they're the downward forces. The upward force, now why aren't we going to say this force up here? Well, that's acting on A. It's not acting on B, so we don't use that. But if you look, there's my two forces. This is not moving, so that means the up force has to be equal to the down forces. So we have to measure these two, and our normal force is the sum of these two forces because it's not moving. So those would be the forces on B, okay? So you've got to be very clear. Only draw the forces, not the components. What I mean by that is, let's say you have something like this. If you wanted to draw this force, then right away you would draw mg. So if you had a dot, you would draw mg. And if you circle it, the forces acting on it are Fn, and that would be perpendicular. The force of the table is always perpendicular, okay? And if there's friction, then friction would be in opposite the direction of the movement. Notice there's no drawing of the force that's pushing it down or pulling it down. That's because that is a component of this force. When you're asked to find that force, then you would use this. mg is your hypotenuse. Fx, the force going in this direction of the movement, would be the sine of theta times mg. So mg sine of theta would give you the forward moving force. But you would never put it on a force diagram because it is merely this component of your mg force. So usually it will say, write the forces, not the components.